find and describe the discontinuities in h of x equals tangent of x. So here we need to remember what the graph of the tangent function looks like. And we will recall that the tangent function is a periodic function with a period of pi halves. So when we label the tick marks on our x-axis, they should be not multiples of 1, not integers, but they should be multiples of pi. So there we go. And remember that tangent of 0 is 0. So it starts at the origin, or it goes through the origin. And then it is an increasing function, but tangent of pi halves is undefined. And so it is going up towards infinity. And then on the other side, it is going downwards towards negative infinity, asymptotically. And this repeats every pi. So at pi, we have the same thing. It's going to go upward towards infinity. And then before that, it goes downwards towards infinity. And the same thing is true with 2 pi, upwards towards infinity and downwards. And we can do the same thing over here. All right. Let's do one more. Okay, something like that. Not a perfect graph, but you understand what I mean. And when we're looking for discontinuities here, there are infinitely many, because every time it finishes the period, we have a discontinuity, and then it goes again, and then another discontinuity. And so we need a way to write this. First of all, what types of discontinuities are these? Well, these are all infinite discontinuities. And we need to write where they're at. And so there's a couple of ways we can do this. One of them is to try and make a list and kind of express the pattern in that list. So here we've got one, this is pi halves, this is 3 pi over 2, we've also got negative pi over 2, negative 3 pi over 2, etc. So we could say that these occur at, let's say, ... negative 5 pi over 2, negative 3 pi over 2, negative pi over 2, pi over 2, 3 pi over 2, 5 pi over 2, ... If we list enough of them, then the pattern might become pretty clear, right? It's at all of the odd multiples of pi over 2. But then there are other ways of writing that. And I want to use this as an opportunity to talk about these, because you might see them in different instances. We said that they were odd multiples of pi over 2, and you can write odd numbers as 2k plus 1, pi over 2, for integers k, right? If k is an integer, then 2k plus 1 is odd. And the way that we write k as an integer is we say k is an element of the integers. I may have just blown your mind here. K is an element, this little kind of backwards soft e means is an element of. And then if we want to talk about the set of integers, it is this z with an extra diagonal slash through it. So that is another way of writing it. And then there's a third way of writing it that still uses this notation, but you can pick one of the discontinuities. So for example, pi halves. So we can say the discontinuity is at pi halves. And then it is periodic with period pi. Every integer multiple of pi that we add will give us another one. So we can write plus k pi. And that's also for k an element of the integers. So we're not going to do a lot of these examples in this class. This is the sort of thing that you'll definitely see if you're a math major in some of the more advanced math classes, but this seemed like a really good opportunity to show you something that you might see later, especially those math majors. So I think it's worth mentioning these different notations. So these are the different ways we can talk about where the infinite discontinuities are in this function.